Yes, good.
Okay. So today we'll see about collection framework in Java. I hope everyone is kind of aware of what is a collection framework in Java. Or, anyone is new to collection framework, you respond in chat. If you are new, you can say I'm new, or if you are have a little bit awareness of collections, you can say that also. Okay, what about others? Okay, okay. So collection is a framework or library in Java, right? To do uh, storing of data at the runtime or at the compile time itself. So we just store the data in a certain format to do so certain operations at the time of program execution, right? Storing of the data in a database is different. Collection is like retrieving the data from the database and using it in the program at the runtime. So basically, most of these items are stored inside our RAM at the time of execution, right? This collection. I'll just there is something called collection hierarchy. I'll just try to show that. Okay. Everyone are able to see my presentation, right? This little presentation here. I
Yeah,
hope.
good.
Yeah.
Yes, good.
Okay. So there are much more in the collection library or collection framework, but this is a kind of basic. I think this is more than enough. Understand what is collection. Uh, we know, right? Everything has a super class which in Java, which is object class, right? And this is the iterable interface which extends to the object class inbuiltly, which we don't know that. This is an whatever in the red is interface, whatever in this green is class, right? So we are having this iterable interface. Iterable interface is kind of a master interface for everything in collections framework. So why this interface is used is to iterate over the elements, because we store the elements in array or list something, right? So to iterate over these elements, we need some iteration class. So we have this iterable interface which provides some methods. So we to iterate over all the elements of particular collection data store which we have. And we have this collection interface itself, which has some methods like sorting and all, which is implemented by some of the implementing classes. And this collection in interface is extended by three interfaces: list, queue, and set. These are the very major interfaces that are extending this collection interface. And this list is implemented by array list, linked list, and vector. Right? And this queue is again implemented by priority queue. And this queue is again extended with dq, and this dq is implemented by array dq. Again, we come to set. Set is implemented by hash set and linked hash set, and which is again extended by sorted set interface, which is implemented by tree set. Okay. I'll just give you the overview of how the data is stored here. There are some more data set called maps, right? We'll come to that later. A list is a collection of sequential elements, right? Array list is an implementation of a list where data is stored in a sequential order in the memory. Linked is also implementation where data is not stored sequentially. It has some random blocks of memory in RAM, but it has some address of each and every element next to it. Right, linked list. And vector is something which is kind of an having the unique kind of elements, right? The list implementation. And queue we all know, right? Queue, what is a queue? Queue is first in first out, right? So that implementation is also provided. And don't worry about this DQ. DQ is kind of reverse implementation of queue. We'll come to that later. Set is something which has always some unique elements implemented, right? Set is something which enforces you to always have an unique element. And this set is implemented by hash set. And this hash set is kind of very useful when you go for programs, because most of the data structure algorithm programs is solved by hash set. Because what is the very useful thing about hash set is it stores element in a unique manner, but the retrieval of the element from hash set is in the order of one. Order of one in the sense it doesn't take, it takes many very minimal time, constant time to take out whatever data is available from the hash set. Even it has some millions of data, all the data is unique, and also the data is taken at a very at a constant time. That is order of one, right? So we have linked hash set where the elements are stored in a kind of sequential manner, even though it is a hash set. And we have sorted set, and tree set also stores a unique element, but in a sorted manner, right? So far, so good. Fine, right, everyone.
Okay.
Okay. So I will just show these things. So this is the master interface, right? Iterable. So as I said, iterable contains some methods which are used for iterating over an element, right? We have this default method. So we are iterating over each and every element, right? Using a for loop. And we have this so we have this collection interface extends this iterable. Important thing to notice that every collection framework is available in the package called java.util. In this package only it is available. This collection extends this iterable. Right? So the collection is a very generic term, right? Collection can be an array, or it can be an linked list, or it can be a hash map. It's a very generic term. So what are the methods available here is also very generic, right? So what are methods available here can be applied for any kind of collections. It may be a list. I can remove all. I can remove if some condition matches, right? I can retain all. I can clear the collection, entire thing I can clear, right? So collections provide, if you want to see this methods, there's a simply shortcut in Eclipse called control O. You can see here what all method it supports. right? And we have this list interface. We'll just see about list now. Uh, there are so many lists available, right? You have to be very, very careful. Different packages have different collections of list. I mean, different list interface and classes. But what we are trying to see is the list available in the java.util.package. This list, right? This list, which extends the collection we saw in the presentation, right? Iterable is there. Collection is extending iterable. List is extending this collection. We have iterable. We have this collection extending the iterable. Just extending the iterable. And we have this list extending the collection. This is also an interface. And it provides some default methods for the implementing classes to use, right? Most important methods are add and remove method, right? And we are just going to focus on those things only. It also provides the sort method. Okay, these are the methods available, and we have this array list class which is implementing this list. Array list, yes, which is extending this abstract list class and which is implementing this list interface, right? So let me say the difference actually. So we saw what's an array, right? We how we'll declare an array. If I want to declare some integer array, it will be something like integer a is equal to new integer. We have to specify what size of array we want, and I can access this particular thing through indexes. Right? So a of um, 0 is equal to 4. A of, let's say, fifth index equal to 7, something like. But what is the biggest disadvantage of this array? Can anyone say? Array is there. Array is there in almost every programming language, right? But generally, what is the biggest disadvantage of using an array?
It's a static.
Say, yes. What do you mean by static?
The size cannot be altered once you
Yes.
define
Yes.
it.
Yes. Yes. Okay, that is true, but don't use the term static because static has a different meaning in Java. Right?
Okay, good.
Because if interviewer is asking this question, he might be curious to know like what exactly you know about static, and so you can say the size is fixed. Don't use the term static with respect to Java because static has different meaning in Java. Okay. So as
Okay.
Shiva said, size is fixed, right? It is very very kind of restricting for the user to have a size fixed at the compile time itself. So it cannot be used for many purposes. Actually, this kind of array declaration is very very fast. Accessing is also very very fast. But the biggest limitation is its size, right? Its size is kind of limited, and you cannot go and increase the size at the runtime. What if some random data we are reading from the database, or we are getting, let's say, we are getting some elements from our Selenium web page itself. We don't know how much elements we are going to get. I can take the list of elements also, or I can read data from Excel. We don't know how much data will be there to use in our Selenium framework for the particular test case. Why to statically, not statically, okay, why to fix something at the compile time itself? Why to fix the size at the compile time itself? Very, very bad programming paradigm, right? So this kind of array declaration is used, but it's used in different purposes. But generally, in real time projects, we used array list to overcome this problem, because in array list you don't have to declare anything upfront. I mean, declare in the sense I don't have to declare the size of the array list upfront. I just have to declare the array list, and as we go towards adding element, I can go and add infinite elements in my array list. The number of elements that we can add to the array list only depends upon the Java heap size that we have configured or declared. Only that is the limit. Otherwise, we can go and add infinite elements in my array list. Okay. That is one biggest advantage of using array list. And can anyone say what is the second disadvantage of regular array? Can anyone think what may be some other disadvantages?
We can't alter the data.
No, we can alter the data. We
Okay.
can alter the data in array, regular array. I have declared a zeroth index as 4, right? I can also in the next subsequential lines, I can modify this data again to some random 100. I can do that.
Okay.
Can anyone think of, or Shiva, like, can you think of what is another disadvantage? It's not a major disadvantage, but still it's kind of small disadvantage when compared to array list.
We can't concatenate.
Okay,
Is that one?
concatenation is limited because we know the size, right? Concatenate in the sense I cannot add something like this. I cannot go and add array of index 10 because array is from 0 to 9. It's not, I don't say it's concatenation, because we don't use term concatenation with regular arrays, right? We use with array list. Okay, what's the problem is, like, we have to access the index and put the data every time. So what if we don't know the index? Either we have to iterate over the array using a for loop, and you have to access the index and put the data in the particular index, or and it's kind of very tough, right? At the runtime, every time you have to know the index of the particular array. You have to know that index where to store the data and all. For example, if there are three, let's say I have the index 7 here, and there are three data stored, and there are the 7 other indexes that are empty, and I wanted to add one more element. So to where I will add? So I have to have some proper implementation mechanisms to solidly know, okay, if I have to add in this index location only, so that it won't create any problem for me, like that. So I have to know previously also. That's also a problem. And this uh, array is of a primitive type, right? It supports both primitive type also. But one thing to note about collection, it's like it doesn't support primitive type. What I mean with primitive type is this int is a primitive type data type, right? Primitive is like if you type in see, if you type in Eclipse, it will show this keyword kind of highlighting. It's a primitive data type. But whereas we can declare the same thing, something like this. Something like this. I can declare an array, integer int array. So this is a wrapper class. This is a proper Java object, right? Integer. We have this integer class here. I will show. We have this proper integer class here. So it is a proper object, right? Whereas this int is a primitive data type. Both works, but we should also understand the difference between the both, and we have to be very careful in declaring this or this at the runtime, because when you use this, integer, then you can go and use what are the variables or objects available and methods available inside this integer class. That is also possible by iterating each and every element over here. But what this array list does is like array list supports only generics. I mean object data type, right? It doesn't support primitive data type. I cannot add int variable to an array list. I can add only integer. This is not supported. I can add only integer. So one important point to note in collection framework is like no collection supports primitive data type. It supports only wrapper classes and other objects. That's very, very important point to note. Right. Okay. And there is something called linked list. Anyone is aware of what is a linked list? So we saw a few things, right? In array list, we can add unlimited data. We can the limitation of the normal arrays, we have to access the index and every time store the data. Normal array supports both primitive data type and wrapper classes, whereas the array list supports only integer, I mean wrapper classes or objects. It doesn't support primitive data type. So this is an array list, and how the data is stored in an array list? It is stored sequentially, right, in memory. Let's say I have memory location M1, M2, M3, M4, M5. How the array stores? Array list is also storing the memory. I mean values sequentially. I have this 4 some random numbers inside the memory. 4, 8, 16, something like this. 5 values in a memory. If I wanted to store in array list, it is also stored in a sequential manner. Consider this all these blocks of memory sequential. That is, these addresses next to each other, right? M2 addresses will be next to M1 in memory. M3 addresses next to M2 in memory. So, what is the advantage of having this kind of pattern? It is very easy to move to the next element. We know where is next element when we are here, right? When we are in the element M2 in memory, we know what's the next element because next element is the next address. It's very easy to iterate over array list, right? You're getting the point? If you can respond, it will be very helpful for me.
Yeah, correct.
Okay. But what is the biggest disadvantage of having such implementation? It's very easy to know what's the next element and where's the next element. I can look at the next element by looking at the next index itself. Because, for example, if I'm index 5, I can just look at the index 6 to get the next element. I don't have to look at anywhere because index 6 will look for the next memory location in our RAM. But what's the biggest disadvantage of some implementation like this? Can anyone think what's the biggest disadvantage?
So I think you need to have a sequential memory. Like all the elements should be like in the memory block. The all the bits need to be side by side. Like
Yes.
cannot assign different like each element in different parts of the memory, but you need to have a sequential place in the memory.
Yes, memory. I mean, data is stored in sequential place, and that is how array list is implemented, or even normal array is implemented. But what's the kind of disadvantage of using some memory structure like this?
It's not sorted. It's
No, not necessarily be sorted. It can be 41 also. Sorting is not an issue. It can be 41. It can be 60. It can be even -8. Sorting is not an issue. So if you think in a logical perspective, I'm putting some random elements here in a sequential memory location. What if I want to remove this element 60? Suddenly I'm deciding I wanted to remove this element 60 from my array list or even normal array. I don't want this. Even if you go and remove this element, you cannot go and remove a particular element, right? Once you declare this memory is created, just think of scenario where I can go, for example, I have declared this array of index, fifth index is equal to 7, right? Now, even before declaring this value as 7, what is stored in this fifth index? See, let's say I have this integer array with the 10 locations, right? I have initialized only 3 locations, 0, 5, and 7. What is the value that will be present in the second index, right? It will be either 0 or 1, right? Some default value will be initialized, and some it will be assigned, unless we explicitly specify some value. So that is the biggest disadvantage, right? We cannot remove an element. It can be it should hold some value. It cannot be entirely removed from the memory block. For example, if I try to remove the 60 from the memory block, then I'm directly violating the concept of array list itself, because if let's say this m3 memory, it's not that I'm just removing this entire 60 from the memory. Now this m2 and m4 are not sequential. Now I cannot access this -8 by just looking at the next memory address in my RAM, right? Because next memory address will contain null. It doesn't contain any, or if it contains some arbitrary value which we don't want. So what an array list will do, array list will immediately see the next address, and next address, if it is null, it will terminate the program, right? You will think, okay, there is nothing after this because next memory location is empty. So these values are totally ignored, even though it is present in the M4 and M5 memory location. And what if I wanted to add something in between? That is also a problem, right? Assume that, let's say, okay, assume that M3 is there and 60 is there, as we saw previously. Removing is a problem, right? But what about adding? Adding is also a problem, right? I have something like this, but what I wanted to do, I wanted to put an element between 7 and 60, like this. I want to put some element called 44 in between. But 44 will store where in the memory location M3, but in this M3 already 60 is present. Either it should replace. If it is replacing, the 60 will be gone. We should have 60 also, right? So now what is the solution? I have to go and create this memory location called M6. I have to shift each and every element, right? I have to shift the 16 from M5 to M6, right? I have to shift this -8 from M4 to M5. I have to shift this 60 from M3 to M4. Then I have to put 44 inside M3. So everyone getting the point? Right? So it's very costly operation, right? For it's a simple 6-element array. Fine. What if the array list or array contains some millions of elements? I am going to shift millions of elements in the right or left just to add one particular element in one particular array. So that is very costly operation, right? And implementation is also very difficult. So biggest disadvantage of an array implementation like now regular array or array list is inserting and deleting an element in the middle is very costly operation, and it is not advisable to do so in an array list. That is one thing we have to know, and this is a common question also. And if you go for some interviews, right? In some good companies, this is a common question asked, right? What's the difference between what's the limitation of array list and where you should not use and where you should not use? So array list should be used when you wanted to already some predefined values are there and we initialized an array, or if we keep on adding the elements at the end of the array, that's not a problem. But when you try to insert and delete an element from middle, we can do that in an array list, but it's a very costly operation. We should try to avoid doing that, right? So inserting and deleting has to shift all the elements to the right or the left and putting or removing the element from there, you know. So those are the big limitations. We'll see some examples. Okay, before moving to example, one more important thing of collection framework. Why collection is extensively used? Because of something called type safety. We'll see what is type safety shortly. Type safety is like, if I declare something in an array list of integer, then it should be staying as an array list of that integer only. It should not add string or double value in between. So that is directly violating the Java's type safety protocols. But remember that you can do that something do similar to this something in a programming language like Python. Python supports adding multiple data types in a single entity called list or tuples, but Java generally doesn't support that. Okay, we'll see some examples. Let's create a package collections test. What we'll try to do, we'll create an class called array list test. We'll create a main method also. So generally how you can create an array list is like either you can do something like this. List is an interface, and this array list is kind of implementing the list, right? Implementing the list, right? So what I can do, you see something called this angled brackets, like this is called generics. We'll cover generics later, but generally generics is used for something called type safety, right? uh, let's see what's the type safety here. I just wanted to create an array list. What I can do is like I'll just create a list first, create an angular brackets, something like this. So what type of list I wanted to create, for the time being, I'll just create a list of integers, right? Let's say I'll name this as list itself. Is equal to new. I cannot go and give a list here because it's an interface itself. It will throw an error. Let's first import this. I have to import from java.util package, right? It will throw an error because list itself cannot instantiate because it's an interface. So what I can instantiate, I can say new, I can say array list. Right? Array list of what? Integer. Close the brackets and you are done, right? Import the array list from java.util.package. So this is how you declare a array list in Java. Whatever you mentioned this inside this angular bracket is called type safety, generics, right? So when I say it's an integer, inside this angular brackets, then I cannot add some string value inside this array list. So this is to make sure at the compile time itself, then this is type safe, then I don't have to mess up with anything. If you try to add something integer, it will throw an exception, right? You cannot add an integer at all at the compile time or runtime, right? One more thing which I wanted to show is like, if I try to do something like this, it is throwing an error, right? I cannot add a primitive data type here. I can add only a wrapper class and object here, right? So that is one thing. So if I want this list is an empty list, right? Currently, so if I wanted to add something to this list, I can use this methods available here. If I just use this object and click dot, it shows the list of methods that are available in this list interface or array list class, right? So if you see, I have an add method, add all method. I can have a collections of certain element, and I can add n number of elements entirely at a single shot. I can clear the entire list by this clear method. It will wipe out every element in that list. I can check contains whether this array list contains some element or not, and I can check whether equality of this element. I can get the index and object inside it. I can get the last index also, right? These are important methods that we have to note in array list. I have this remove also. Come to remove part later. I can remove an element from an array list. So I can replace certain element. Right? I can get the size of array list. I can sort. Okay, these are general thing available, but most important method that we have to notice is this add method. I can go and add some element here, right? I can add 5 here. Right, I can add elements, and to see what is available in this list, I can iterate through element and I can print it. I can use a for loop. So let's try to run this program. So it is printing the element, right? So I'm just adding the element in this array list. I'm just printing the element. So far so good, right?
Yes.
Okay. So what I can do, okay, let's try to add something string like this. So it throws me an
This is
error.
very important.
Sorry?
Okay, yeah, carry on. Actually, I was telling that this list is very important when we are using taking collection of elements
Yes.
in document object model.
Yes, right. Okay, so it's throwing me an error, right? So it says, hey, you are declare list of integer, but the argument is string, right? So this is an important concept of type safety. So whatever you declare as this class, then all the subsequent things that are applicable to this array list should be of type integer only. It cannot be of any other type. Because if you go to this list, you have this type safety check. And if you go to this array list, this E is there, right? If you add this E represents element. Right? Generally, there are some notions of type safety. you would have seen something called T, caps T. Caps T generally represents type, and this E represents element. And we also use some notations called K and V. K and V generally represents for key and values. The general notations which we use. Let's see this add method here. This add method takes what? It takes element E of type E itself, right? This E where we declare in the initial itself. So whatever we declare here, that element only can be added here in the add method, right? Because it is of type that E itself. So in our case, E is integer. So only it is not allowing any other kind of string kind of variables to be added in our array list. Right. We'll come to this generics later, but this is how it is implemented, right? Everywhere you see the generic element will be used, right? So, okay. This is how we print, and we don't have to necessarily add every element by just using this add method every single time. Also, I just can use this for loop to add the elements also. So I'm just iterating through 0 to 5, and I'm just adding the numbers by multiplying it by 10. So now our array list will contain some 9 elements, right? So I can add our elements through iteration also through some logics which we have in our program, right? So what if I wanted to add some element in between, right? But as I said, that's a very, very costly operation, right? Let's see. So previously we got the output as 5 minus 3 40 22 0, right? Let's try to run this. So now it is adding an element in between, right? In what index it is adding? It is adding at the index 1. And what it's has done, can anyone see the difference here? It has added an element in the first index in -2, and it has shifted every other element to the subsequent index, right?
Yes.
Yes. So, okay, this is the method to do that. We have declared index and we have given the element also in the argument. And this is a very, very costly operation, right? So we have to copy this entire thing here in a separate thing. We have to check for the range. There are so many things to do here. It's kind of not advisable. This is only advisable when you are having some small arrays, but when you are having very huge arrays of lakhs of data, it's not at all advisable. Let's try to do this. Okay, let's try to do one more thing. Let's say 19 itself. So when we try to access this index 19, it is throwing an index out of bound exception, right? Why? Because there is no index 19 at all. We have just have index 0 to 10, right? we are adding this 4 things here, and we are adding some more 5 things over here by iterating, by adding. So I cannot just add some random index into our array list, because it again violates the concept of array list. Because for example, in our example we have only 10 indexes. I'm adding something into 19th index. Now what happens for the values that are between the indexes 11 to 18? Now it is null or empty or some random arbitrary value. Now it violates the concept of having sequential data in the memory, right? So we cannot do something like this. This is prohibited. And please note that it's not throwing any compile time error. Only error you are getting is a runtime. We saw some exceptions, right? Array out of bound exceptions are runtime exception. It's not. It's an unchecked exception, right? So you have to be very careful with these things also. If you wanted to add 19, it's always good to add 19 directly, like this. So it will add at the last, and it will create an index out of that. Right now, it's going to add at the last. Right, 19 is added here. Right. Let's try to do one thing. Let's try to make this as large element like this. We'll not print this because printing it's going to take a lot of time. Let's try to run this. Okay, maybe let's try to print something. Okay, it has still done very fast. Let's try to increase this. Okay, integer itself has limitations. Okay, now it's taking some time to do that, right? Program is still running, if you can see here. Let's see how much time it's going to take. Yes, it took some time, right? Maybe 10 seconds it took, I think. And if you keep this as long instead of integer, if you remember, we have to add that L at end to let know that it's a long, right? Let's verify with this small number. Okay, I think this. Okay, now it is adding. Let's do with a large number, something like this. Okay. Long only declared. Now it's taking a lot of time. One thing to note is like there is something called exponential behavior of these functions actually. What we have noticed, like for example, if I just add one more zero here, it is not going to take the 10 times of the time, it is going to take the exponential of the time. So the time complexity of the any particular program with respect to input doesn't increase linearly, it actually increases exponentially. That's the one thing which we wanted to note. You have to be very careful in this. For example, okay, it's not going to stop. It's a very huge operation. We'll do it manually. Even some computation may take some 30,000, 40,000 years to compute if you don't have the proper check of this time and space complexity. So only it's very kind of important in programming world. For example, okay, let's convert everything to int back. Right. For example, if I have some 50 iterations to do, it is going, let's say it's going to take some 10 millisecond. What if I have some 500 iterations? 50 and 500 is 10 times difference, right? So now my 10 milliseconds will not become 100 millisecond. It's going to be even more. So what I'm trying to say is like this particular time is not linear with respect to increase in data. It is actually exponential. So we have to be very careful with that. If you are interested, like you can go and verify the time complexity, what is time complexity and those stuff. It's kind of very interesting topic actually. I mean, everyone is getting my point here.
Yeah, Karthik.
Okay, let's try to do one more thing. We'll try to remove some values here. Okay, before that we'll try to run this program one more time. We'll remove this line itself. So I have 10 elements. The program is terminated. I'll just try to, okay, before that I just wanted to show one more thing. I can do a for each by some other thing also. There's one for each method itself available inside this iteration. It was kind of implemented from Java 8 actually. I can just declare an object L, something like this. I can use some lambda function like this, and I can print directly like this. Instead of using the heavy for loops, I can do something like this. See, this is a kind of for loop which uses this lambda notation to print each and every element here. I can, if I go and run the program, I get the same output, right? But there are some limitations for this lambda program. For this for loop, we'll talk about this maybe some other time. But know that iteration can be done through in this way also, right? Okay, we'll just see the removal. I have certain 10 elements here. What I can do, I can go and remove some element. Sys out or list dot remove. If you see this remove, I have this for remove method, right? Either remove by index or remove by object itself, or remove by having the collections of set of integers to remove as a whole. and have this remove if some element matches, some condition matches, right? We just focus on the first two things, remove and the index and object. We'll just try to remove from index. I'm just removing the first index itself. So in first index, what I have this 5, right? Let's try to put this at the beginning actually. Now previously we had the 5 in the first index. Let's try to run this program. Now that 5 is removed, right? Again, removing is a very costly operation again, right? Because how the array list will be indexed, it will be indexed from 0th element is 5, first element is -3, second element is 40. Now if we remove this index itself, now what happens, every element has to be shifted one time previously to the previous memory location, and the last memory location should be deleted. Again, it's very costly operation, right? Adding and removing. So but this is how remove works. So I can go and remove something random in between also. Let's try to remove the, okay, let's try to do 4th element. Now after removing 5, what will be the 4th index? -3, 40, 22, 19, 0. 0 will be removed, right? Try to run this again. Yeah, 0 is removed, right? Because 0 is in the 5th index. I mean 5th element, which is in the 4th index, right? So 0 is removed. Now I can also remove an object itself, right? You see there's one more remove method called object. I can say new integer of let's say I want to remove 40, right? Now this 40 here in the last, I'm trying to remove this. Let's see what happens. Okay, I have 40 here also, right? Okay, sorry. Let's try to remove some other element. Let's try to remove this 22. Okay, now 22 is removed. Why this 40 is remained in the last is like the 40 is already present in the previous. We added 40 here itself. So when you removing the object, it will always remove the first element that it is encountering in the list, and it will remove that element only. You have to always note that when you are removing as an object, and whether and it will give a boolean as an output whether that element is removed or not, right? So if you see, this is a return type is boolean. If it's removed, it's returned true. It is not removed, then it returns false. But this remove method will return that integer itself. See, it's returning the return type itself, right? So its return type will be the integer itself. For example, if I try to do something like this. Okay. Okay, it should return the integer itself. I'm not sure why this is not printing. Maybe I'll check and get back. But ideally, this remove method, it's returning the value itself, right? So now this element is integer in our case. Now whatever element we are removing, it should return that element itself, right? So ideally, what should happen is like whatever we are removing, it should return that element, and same should be printed. Maybe I'll check this and get back. Right?
Yeah, one try we can do, like the integer dot parse int. Maybe some it is trying to pointing some memory location.
But even that memory location should have been printed in the console. I'm not sure why it doesn't print.
Yeah.
Okay, maybe I don't know if that will work.
Yeah. Oh, okay.
No.
It has to be converted to string.
Okay, maybe I'll check this and maybe we'll discuss this tomorrow. But generally, it should return. Maybe I'll check this. So the idea is like removing is possible through the index and what to say, and but you also have to remember that removing is a costly operation, right? I can remove either through index or I can remove through object. So when I remove through the object, it is going to encounter the first element or whatever it is present, and it's going to remove that only. It's not going to look for second element. It will return true or false whether I removed or not. So I mean, those are the important things which we wanted to note. Right? Maybe we'll do a sys out of this. It's returning true here. So it says it is removed. Right. Okay, I think okay. I think it has worked. We only didn't notice actually. This line has worked only. Okay. We are removing the 0th index only, right? And it's removing the 5th element only, right? Element 5, which is index 0, and we are printing the same element only, right? So only it's printing 5. I didn't notice. Sorry for that.
Oh, yes.
Okay, right. I was confused.
Right.
Okay. Right, it's printing only. It's working as per expectation. Okay. So we are maybe this index 0 is confusing. We'll try to remove from index 7 or something. Right. Now it's printing 20. Yes, 20 is removed. Now it's printing 20. Right, and the remaining elements are printed. These are the actual elements which are present in the list after removing. Right. Okay. Fine, right, everyone?
Yes.
Okay. Okay, I think we can wrap the session with this. We'll continue tomorrow. What about others? Fine, right?
Yeah, got.
Okay. Okay, we will.
Yeah. It's fine.